5.2 is binomial probabilities. So a binomial experiment is used in problems where there are exactly two possible outcomes for each trial. So features of a binomial experiment are we have a fixed number of trials, n. They're independent and they're repeated under identical conditions. With a binomial experiment, your two outcomes are either success or failure. P is your probability of success. Q is your probability of failure. When you add those two probabilities together, you should get 1 because it's one or the other for your options. The central problem of binomial experiment is to find the probability of R successes out of your n trials. So for example 1, on a TV game show, each contestant has a try at the Wheel of Fortune. The Wheel of Fortune is a roulette wheel with 36 slots, one of which is gold. If the ball lands in the gold slot, the contestant wins $50,000. No other slot pays. What is the probability that the game show will have to pay the figure to 3 contestants out of 100? So when they ask for how many trials, that's your n. So we're doing this 100 times, so our n is equal to 100. They want to know if the trials are independent. Yes, because one spin does not affect the next spin. For part C, what are the two outcomes possible for each trial? You have a success where you land on gold or a failure where you don't land on gold. For D, what is the probability of success for one trial? What's the probability of failure for one trial? So we know that only 1 out of those 36 slots is gold. So that means my probability for success, so P, would be 1 out of 36. My Q is my failure. There are 35 slots then where you don't win. So 35 out of 36. They want to know how many successes are we trying to find? We want 3 contestants to win. So that means our R is going to be 3 because we want 3 successes. Now for this next one, I want you to try this one. So pause the video, read through everything just like we did in example 1, see what you can do on your own. Okay, so you should have answers for A, B, C, and D. So it says, according to the textbook of medical physiology, 9% of the population has a blood type B. Suppose we choose 18 people at random from the population and test the blood type of each. What is the probability that 3 of these people have blood type B? So I want what's success and what's a failure. The success then would be that they have the blood type B. So they have type B. Your failure then would be if they don't have type B. For part B, it says, what is the probability of success? What's the probability of failure? Our success was 9%. So that's not 9, it's going to be 0.09. Remember, when you change your percent to a decimal, you move it to the left 2 spaces. So then for our failure, we take 1 minus that 0.09, and that means we have a probability of failure to be 0.91. They want to know how many trials. We're looking at 18 people. They want to know how many successes. They want 3 people to have blood type B, so your R would be 3. Now it's important that we know how to find all these parts because the next part is actually putting it all into our calculator to actually find the probabilities. So you need to know how to find what your N, your P, and your R are going to be before you can start typing things into your calculator. Here I have a nice list of how to type stuff into your calculator and what to do. So please keep going back to this list so you can remember how to type things in. Now we're going to be doing a PDF and CDF. PDF is when you have R equals a number. CDF is when you have R is less than or equal to a number. So depending on what we're talking about when we look at our R, you're either PDF or CDF. So again, flip back to this page because this will tell you exactly what you need to do, how to type it in. Now, what you're going to be given is story problems. So they won't come out and say R is greater than or equal to 4. You'll have to make sure you're reading for clues to figure out if it's greater than or equal to, less than or equal to, greater than, or less than. So for example 2, it says privacy is a concern for many users of the internet. One survey shows that 59% of internet users are somewhat concerned about the confidentiality of their email. Based on this information, what is the probability that for a random sample of 10 internet users, 6 are concerned about the privacy of their email? So going through it, we have exactly 6 out of 10. So you need to have 3 important parts when you go through these. You need to know what your N, your P, and your R are going to be. Here it tells us we have 10 users, so our N is 10. Next, we have a 59%, so 0.59 for our probability of success, and we want 6 exactly to be concerned. So what we're looking at is the probability that R is equal to 6. So if you go back to the last page, when it equals 6, that's your PDF. And it says how we write this is we put our N, then our P, and then our R. So to get this on the calculator, I'm just following what the steps say. You're going to hit your second button, and then you're going to go to your VARS button. And now you want to find binomial PDF. So we have to scroll down. So you have PDF and CDF. We need the PDF one. So you're going to hit enter. Now some of your calculators pop up like this where they'll actually lead you through it. Those of you, if you have an 83, it's going to be written all in a single line. So you're going to have to do 10, 0.59, 6 parentheses. You'll see how it looks once I type everything in. Those of us with the 84s, you'll type in your 10 for your trials. Your P is going to be 0.59. Your X value is 6. Same thing as your R. Hit enter for paste. Now those of you that had the 83s, this is what should be up on your screen right now. You have to actually manually type it in. They don't have a nice little setup on the 83s. And again, if you're having trouble with it, just let me know. I can show you on an 83 also, or if you look up on YouTube, I'm sure YouTube can show you on an 83 also. So here is our PDF. I hit enter. There is my probability. Now WebAssign will tell you how many decimal places to go. If I want 3 decimal places, 0.250. Again, WebAssign will tell you how they want you to round it. Okay, so biologist is studying a new hybrid tomato. It is known that the seeds of this hybrid tomato have probability of 0.70 of germinating. The biologist plants 6 seeds. What's the probability that fewer than 4 seeds will germinate? So we're fewer than 4. You've got to find that up at the top of this page to figure out which of those inequalities to use. We want fewer than 4. So we have 6 seeds, so my N is 6. Probability, they tell us that's going to be 0.70. Now we've got to do our R. If it's fewer than 4, we want less than 4. So when we find our probability, we want probability that R is less than 4. This is a tricky one. You're going to need to go to the other page to see how you're going to type that in. If it's less than, it's binomial CDF. Sorry guys, I'm also a teacher here at school, and we have our announcements going on too. So once those announcements are done, now I can keep going. So I have my binomial CDF. We've got 6.7. Now if you look at the list on the last page, it says you take R minus 1. So we're going to do 4 minus 1 to give us 3. Because if we want fewer than 4, we're saying I want the sum of the probabilities 3 and below. That's what fewer than 4 means. You don't include the 4. So again, we're going to go second vars. And we want to scroll until we get the CDF now. So binomial CDF. I've got 6.7 and 3. So that should be what you have on your calculator for those of you with 83s. And it shows me if I do 3 decimal places to be about 0.256. Now for part B, we want at least 4 seeds will germinate. So we still have 6 for our N. We still have 0.70 for our P. Now if we want at least 4, that's greater than or equal to 4, because you're saying I want 4 and bigger. Now look at the last page to see how we write that into our calculator. So I want the probability R is greater than or equal to 4. That's going to be 1 minus this time. Whenever it's greater, we do 1 minus, because binomial CDF is only less than or equal to. So we do our 6.7. Now, if you look at the other page, it says if we're greater than or equal to 4, we want to put 3 there. Because when you are writing this, you are saying, I want to get rid of all the probabilities of 3, 2, 1, and 0. I only want to find the probabilities of having 4 seeds, 5 seeds, or 6 seeds total. I don't want 3 seeds, 2 seeds, 1 seed, or 0 seeds. So I got to get rid of all those binomial probabilities so we can only find 4 and above. So when you type this in, you must type 1 minus first. And then we're going to do our second vars. We're going to go down to binomial CDF. And we've got 6.7 and 3. So we should get then a 0.744 for our probability. Again, you got to pay attention to the wording of these to know which way it goes. Now, you should be showing me your work as you go through these. For your test, if you don't show me what you're typing into your calculator, I can't give you partial credit. So if one of these problems are like 5 points and you completely have it wrong, I can at least give you some points for knowing that it was the CDF or PDF, for at least knowing what your N was, your P was. Even if you don't get the R correct, I can at least give you some points. But if you write nothing and just give me an answer, I cannot give you any partial points. You would miss 5 points on this problem. So I have to stress, show me what you are typing into your calculator. Write it out just like I did here in our notes. Because I've had many students miss a lot of points because they do not show me their steps. Okay, I'm going to have you try this one. Very similar to our last one. So going through it says, a really performed and somewhat risky eye operation is known to be successful in restoring the eyesight of 30% of the patients who undergo the operation. A team of surgeons has developed a new technique for this operation that has been successful in 5 of 7 operations. Does it seem likely that the new technique is much better than the old? So again, you are going through and answering for these 4 questions. So I'm going to stop now and you're going to pause the video and then you're going to go through and answer those. Again, just try on your own to see what you can do and then play the video for the rest. So for A, they want to know your N. We're looking at 7 here for our operations. Our P should be 0.3. And your R, you are looking at 5 successes. So for B, they want the probability of exactly 5 successes. So that means we want R equals 5. So that's going to be your binomial PDF. And we've got 7.3 and 5. So again, I go second vars. We want the PDF. So I have 7.3 and 5. So it looks like we should have 0.025 for our probability. Next one, we want the probability of more than 5 successes. So if you want more than 5 successes, it should be R is greater than 5. Now remember what I said, whenever it's greater, you're going to start off 1 minus. So we're going to start with then the 7 and 0.3, but think what this means. We want 5 greater. So if you want that to be bigger than 5, that means you want 6 and 7. You don't want to include 5 in it. So you are doing 1 minus everything 5 and below because you only want the probabilities of 6 or 7 successes. So we include the 5 with it because I want to get rid of everything 5, 4, 3, 2, 1, 0. So now when I type this in, we got to do 1 minus first, second bars, and we want our CDF. So 7.3 and 5. So it looks like we should have 0.004. Then for D, they want you to find the probabilities of at most 5 successes. If we're at most 5 successes, we're less than or equal to 5. So since it's less than, you can just do your binomial CDF. We know it has to go 7.3. But now if we want 5 and below, we want to include 5 in our answer. Because you're saying, I want the sum of 5, 4, 3, 2, 1, and 0 of all those probabilities. So we're going to do second vars. I want binomial CDF. And we've got 7.3 and 5. So we should have then about 0.996. Again, as you go through these, you really have to make sure you're reading as to see what you need to do to type things in. Make sure you are showing your work, at least writing down what you're typing in, because everything can be done on your calculator. When you get to WebAssign, look at my WebAssign help. That might help you see how to do some of these problems or how to set things up and get you started. But if you do have questions, as always, just send me a question. And I'll get back to you as soon as I can as you're going through your WebAssign.